In section 1.7, we're going to be working with inverse trig functions. So we're going to work on evaluating graphing inverse sine functions and other inverse trig functions, and then also taking a look at the compositions of trig functions. So that's a little tricksy. All right, what's important here is when you think about the inverse function, now remember, the inverse sine function is different than the cosecant function. Okay, remembering that when we talk about the inverse sine function, the sine function allows us to identify the value of sine based on knowing the angle, whereas the inverse sine function allows us to find the angle based on knowing sine. So this is different than the cosecant function. All right, and when you think about what's going to happen with this function, if I find its inverse, is it's going to rotate in this direction. And the reason that it only has an inverse function on this interval is because if we included more of the function, then it wouldn't be a function because it would violate the vertical line test. So what we want to work with is that our domain is from -1 to 1, and our range is from -π/2 to π/2, assuming that we have the period from the parent function. All right, so that's just, it's mostly that it stops being a function. You could certainly create this curving line in this manner going upward, but you can see that it won't pass the vertical line test, and consequently it's not a function. So that's the reason for the limitation on the domain. Okay, so if we go through, first we're going to just work on evaluating the sine function. So we want to find inverse sine of 1. That's the same, arc sine is the same as inverse sine of 1. And again, remembering from the unit circle, sine is related to the y-coordinate. Where's the y-coordinate 1? It's right here, right? Because this is 0, 1. So it would be at π/2. Okay, and if I want to find the inverse sine of -2, that becomes a little more complicated, so I might want to go ahead and pull out a calculator. Okay, so I'm going to go ahead and do 2 negative and find the inverse sine, and it says, oh, it's not a number. Okay, so this one would be not possible. Right, and if you remember back our limitations on our domain, that makes sense because this is outside of our domain. Okay? So if we want to go ahead and graph this, right, remember our domain is going to be from -1 to 1. If we were going to take a look at what I'd kind of like to do is I'd like to think about the nature of inverse functions first. So if I wanted to graph y is equal to the sine of x, this is the inverse of this, then if you think about my inputs and my outputs, I would find that my period would be equal to 2π. And my inputs would probably have normally been π/2. Now remember, we want to work with values between -1 and 1. What I want to look at is, so the inputs I normally would have done would have been 0, π/2, π, 3π/2, and 2π, with a period of 2π. And with an amplitude of 1, in this case, I would have had 0, 1, 0, -1, and 0. Now, if you think about what an inverse function would be like, in inverse functions, the y's become the x's, and the x's become the y's. Right? And the only thing that's problematic with this is that we could use these values here between 1 and -1. But what they've asked us to do is to go between, to keep a range of pi and negative pi over 2. But if I'd gone in the other direction, between pi over 2 and negative pi over 2, when I went back from here, I would have been back at -1. Okay, so if we think about the sine function, let's say this is 1, 2. So I was using black for the sine function. 1, 2, 3. Let's call that 2 pi. This is pi. This is negative pi. And if we look at this, here we would have been at, let's call that 1 and 1. So here we would have been at -1, 0, +1, 0, -1, 0. Right? So the graph would look something like this. Now we want to work with the limitations that we're after here. So the points I'm going to use are going to be these points here plus the inverse of that one. So -1, negative pi over 2, that would be 1 point. 0, 0 would be another point, and 1 pi over 2 would be the other point. So at -1, I'd be at negative pi over 2. Let's say that's here, right? 0 and 1. So it follows the same sort of path. Right? But my scales are different, so that's really not particularly fair. Right? I would have to go ahead and take this scaling off, because when I invert it, also now this is pi over 2, that's pi, 2 pi, and then this is -1, 1, so -1, -2, 1, and 2, negative pi, -2 pi. So at -1 would be at negative pi over 2, which would be here, 0. Right, so that looks like that. Okay, so hopefully I didn't confuse you too much with the idea of remembering that when we studied inverse functions, the inputs of one are the outputs of the other, and the outputs of the first are the inputs of the second. Okay, so we've got all these different important things to know about limitations around domain and range. Okay, and with tangent, it's a little different, right? When we take this tangent function and we lay it down, it's not going to violate the vertical line test, but we also will still have this restriction on the range. Okay, and what do they look like? This is the one we just did. The sine function looks like that. The cosine function looks very similar. You see it's basically reflected. And then the tangent function is starting to look a lot like the sine function. Okay. If we just want to evaluate trig functions, this is pretty straightforward. Again, cosine is related to x. So where was x -1? It would be over here on my unit circle, right, where x is -1. So that would be pi. Okay, and if it doesn't tell you to work in degrees, you should be working in radians. Okay, now I'm going to go ahead and use my calculator if I want to do inverse tangent functions. So if I have 4.84 and I want to find the inverse tangent, it's, oh, I'm in degrees, excuse me, my mistake. I want to be in radians. So if I have 4.84 inverse tangent, it's 1.367. If I want to do inverse sine, so 1.1 negative, and we want to do inverse sine, not a number. Remember, I have a domain restriction on sine. It can't be below -1. Okay, and if we do cosine, 0.349, opposite cosine, it's 1.93. We'll call that 1.93. Okay, pretty straightforward. We could convert these into having pi in them if we wanted, but it's not really necessary to do for the purposes of this exercise. Okay, so again, when we start talking about compositions of functions, so we're talking about how do we combine our functions and what happens. Okay, now again, we've got domain restrictions and for either different function. And then we've got sine times arcsine, right? So sine and the inverse of sine will get rid of each other, right? So if we're combining these, compositing a function with its inverse, the functions themselves will go away and just equal x. Right? These are some properties that you would want to know. And they're also guidance in terms of moving along forward and solving equations. Okay, so if we want to take a look at this, we've got to see, do these meet these particular conditions? So I'm actually going to copy this and bring it on to the next page and say, all right, it's probably a little too big, but let's remind ourselves that we've got these limitations that we're working under. So if x is a real number, right, in this case x is -14, right, so tangent times the inverse tangent of -14 would be equal to what? It would be equal to -14. They cancel each other out. So when you look at sine of 7 pi over 4, you can see that we're not really between pi over 2 and -pi over 2. If we think about 7 pi over 4, that's just about 2 pi. Right? But what we can look at, we talk about 7 pi over 4, it's over here, 7 pi over 4, but that's coterminal with -pi over 4. Okay, so we can use -pi over 4 in here, right? Pi over 4, that's going to be like the 45-degree angle. I know it's going to be, the y coordinate's going to be negative. It's going to be -√2 over 2, right? Right, and that's going to get us on to -pi over 4. Okay, so if we can work with a coterminal angle, that will work out and keep us within these guidelines here. And here, cosine, arc cosine, this certainly fits within, it'll just be 0.54, where the cosine and the arc cosine cancel each other out. Okay, that's the way you go through these guys. Now this is a little different. Right, so now we want to do tangent of the arc cosine of 2/3. So if I go ahead and go back to my calculator and I have 2 divided by 3 equals, and I find the inverse cosine, I get 48. And if I go ahead and take the tangent of that, I get 1.12. Okay, so as you're working through these things, these composites can also happen. You just have to work through doing the individual tasks in the correct order. So this is going to be 0.6 and it's negative, and I want to find the inverse of sine for that, and it gives me negative 36.87. And if we go through and find the cosine of that, I get 0.8. Okay, pretty straightforward, pretty simple stuff. Right, so we went through inverse sine functions and we graphed them, and we did some valuations. We did inverse cosine, inverse tangent functions. We didn't exactly graph them, but we talked about what they were going to look like. You'd follow the same sort of patterns we did for the sine function. And then we went through the inverse properties of trig functions, and we did compositions with trig functions. That's it for 1.7.